Dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076. Again, I am repeating our number, which is 98367930076. And if you have any mathematical query, doubts, or anything, so please feel free to contact us via these contact details. That means the contact number, or you can drop an email to our email ID, which is souravsirclasses@gmail.com. Okay, so please feel free to contact us if you have any doubts, any queries. So you can join our regular batches, you can join our doubt clearing sessions, and you can join our one-on-one sessions or online classes, so that will be beneficial for your upcoming examinations. Okay, like ISI CMI entrance examinations, etc. So please feel free to contact us via these contact details. Okay, so now we are going to solve a problem which is appeared in the ISI MTech QROR uh, ISI MTech QROR MCQ section, and the question is telling us that for alpha belongs to if alpha belongs to R, that means alpha is a real number with alpha not equals to 0, then the integral minus infinity to infinity x e to the power alpha x minus 2 mod alpha x dx equals to this. So there are four options which are 10 by 9 alpha to the power minus 2. Option B is 10 by 9 alpha into mod alpha to the power minus 1. And C is 8 by 9 alpha to the power minus 2. And D is 8 by 9 alpha into mod alpha to the power minus 1. Okay, so these are the four options of this integral. So we can take the integral in or divide it into two parts. That means integral 0 minus infinity to 0 e to the power alpha x. Then our x is less than 0, so that will be plus 2 alpha x dx. And either case, that means the second part will be 0 to infinity, then our x will be positive, so we will get this. So that is equals to minus infinity to 0 x e to the power alpha 3 alpha x dx. Sorry, that will be minus 2. So plus that will be 0 to infinity x e to the power minus alpha x dx. Okay, so after that we can rename it into two names. That means let us call it I1 and let us call it I2. So now after that we can write it as in I1, let our 3 alpha x equals to u with the substitution of it. Okay, so 3 alpha dx equals to du. Okay, so this integral I1, which is equals to minus infinity to 0 x e to the power 3 alpha x dx, that will be minus infinity to 0 e to the sorry, our x will be u by 3 alpha and e to the power u, and dx will be du by 3 alpha. So we can write as 1 by 3 alpha whole square into minus infinity to 0 u e to the power u du. Okay, so now let us take our I2. Our I2 is equals to 0 to infinity x e to the power minus alpha x dx. Then let us take v, that is equals to minus of alpha x, sorry, yeah, minus alpha x equals to v d. Then what will happen? Then minus alpha dx, that is equals to dv. Okay, so after that what can be done here? So my integral will become v by minus alpha, then e to the power v, and that will be dv by e to the power, sorry, dv by minus alpha. So that is 1 by alpha square 0 to infinity v e to the power v dv. So the total sum of this will be what? So my let me write it with another color. Yeah. So our I is equals to I1 plus I2. That means 1 by 3 alpha whole square into minus infinity to 0 u d, sorry, u e to the power u du plus that will be 1 by alpha square integral 0 to infinity v e to the power v dv. Then that will be what? That will be 0, 0 and that will be minus 1 and that will be 1 minus 0. So we will have 1 by 9 alpha square minus 1 by 9 alpha square plus 1 by alpha square. So that will be 1 by alpha square minus 1 by 9 alpha square. So that is equals to 8 by 9 alpha square. Okay. So the correct answer of this question will be our option C, which is our 8 by 9 alpha square. That means alpha to the power minus 2. Okay. So now again I am telling that if you have any doubts or query or anything, please feel free to contact us via this contact details so you can enjoy all the services of Dr. Sourav Sir's classes. Okay. Thank you guys. Hope you understood.